All right, example 6 for lesson 8.1. A satellite dish has the shape of a paraboloid. Paraboloid is just a parabola that's been spun around in a circle, so kind of, if you've seen a satellite dish, it looks like a circle, but it actually has a parabolic curve to it. If you were to slice it right down the center, you'd be looking at a parabola. The signals that it receives are reflected to a receiver that's located at the focus of the paraboloid. The way a parabola works, specifically a paraboloid, is you have the satellite dish and it's got this receiver up here, right? And the signals are coming straight out of space like so. I should probably draw the signals in a different color. Smart. Let's see. Signals are red, okay? And what the satellite dish does in its curvature is it reflects everything into the focus. So the signal is all in pieces, but as it hits the dish, it gets reflected and all positioned at the same spot in focus. That's where they put the receiver, where all your stuff comes out. So that's how the satellite dish works. Okay. So the focus is the place where the receiver is, and we know how wide the dish is at its opening and how deep it is at its center. We're supposed to determine where its focus is in relation to the center. The easiest way to do a problem like this is to assume that the parabola is pointing straight up with a vertex of 0, 0. You can put the vertex anywhere you want to. You can make it any direction you want to, but the easiest way to do it is straight up 0, 0 vertex. We're going to do that. So what I'm going to do here is, it says the dish is 8 feet across this opening. So the vertex is here, and its opening is 8 feet across. That means if this is the center, we're going to go 4 feet right, 4 feet left. And just for the sake of using some scale here, I'm going to go 0.5 scale. And it's 1.25 feet deep, so 1, 2, 3, 4, 5. I've got plenty of room here. I'm going to go 0.25 scale on the y-axis. All right, so what that means, the vertex is at the bottom of the dish, right? The edge of the dish should be exactly the depth of the dish higher than the vertex. So the deepest part's here. So if I go 0.51, 0.52, 0.53, 0.54, 0.255, 751, 1.25, right there is the 0.4, 1.25. Similarly, go the other way, 4 feet, 1, 2, 3, 4, and up 1 1/4. That puts me right here. This is -4, 1.25. Those points should lay on the very edge of the dish, 0, 0 being the bottom of the dish, and the dish itself is parabolic in shape, so we're expecting a parabola shape out of this. To kind of make a parabola shape there. The concern that we have is, what is the focus? All right. In order to find the focus, I need to find the focal length, and that's really what we're looking for, is the focal length. I know it's pointing straight up. It makes it an up-down parabola shape. X minus h squared plus equals 4p times y minus k. We know automatically that the center of the vertex is 0, 0, which even becomes a simpler structure. X squared equals 4py. Alright, so again, if we center it at the origin, h k is 0, making a very simple structure. What I'm looking for is the value of p. What I know is, obviously that's 0, 0, but I also have this point and this point both lay on the edge of the dish. They lay on the parabola. That's an xy coordinate that I know. So if I substitute x with 4 and y with 1.25, obviously squaring 4 to get 16. That gets me an equation. The only thing missing is p, which is what I'm looking for. If I multiply 4 times 1.25, I get 5. And if 16 is equal to 5p, then p is going to equal 3.2. We divide 16 by 5. So 3.2, the unit of length here is feet. So the 3.2 feet from vertex should be the position of the receiver. And in general, anytime you're dealing with any kind of parabolic dish, that's how you find its focus. The places you see parabolic dishes, obviously satellite dishes, those are also elliptoids. There's ellipses that sometimes you'll have two signals, and ellipses allow two signals. So we can HD in a standard definition signal. There's also, if you've ever watched a football game, they always have those parabolic microphones.
Oh,
They
yeah.
put the microphone out here. They can point that at anywhere, and then all the sounds bouncing all over the place, it reflects and comes back in focus, and you can hear what people are saying hundreds of feet away from you. So it's kind of interesting how that works. But anyway, if you have a paraboloid problem, that's how you deal with it. Works pretty easily. Again, the main idea, the depth of the dish and the width, half the width goes one way, half the width goes the other way. And then you get points, and the points are like you find